Hello and welcome to the 5th episode of the Taped Vibes tutorial series. My name is Sebastian and today I will walk you through the instrument's LUA script. So let's go. Here is my HALion 7 where I loaded the first preset of the taped vibes called a soulful vibe. I'm heading over to the program tree and as you can see there is my taped vibes. And this taped vibes, so the first layer holds my initial taped vibes preset that we have been working for the last episodes. And therein you find the tape, preamp, and so on and so forth. But in this episode, we are only interested in the LUA script. So in this taped vibes MIDI module. We're going to this MIDI module, which holds the script. By clicking on Edit Sound, we're coming to the script module. And we see that the LUA file is held by the VST sound. So, and by going on edit, we are seeing our generic script editor, which is not always that super useful. You can define another text editor for your scripts on the options page, but this only works if your LUA file is located on your hard drive. Another for VST sound, which is our case, this will open up in the generic editor. So let's copy all lines and use our Visual Studio Code. Create a new file with the LUA syntax highlighting. And we are good to go. So this is our full instrument script for the taped vibes. I rearranged my window a little bit so that you can see both HALion in a simplified way and the LUA script, so that we can have a look what the script is doing and how it's affecting the part in HALion. So besides some general author and date information, I always like to make some kind of headlines and comments in the code. First, it helps to structure the code, and as this instrument is not protected, it shall provide you an easy starting point as well. So at first, there are my global definitions. And as you can see, I made a comment, key color for key number 0, pedal noise. You might remember the pedal noise samples are mapped to this little area in the mapping. So on the first key, on the highest velocity, they will be triggered by a script. We will see this later on, but sometimes there occurred some weird issues where this part of the region was also colored in white, and to avoid this I manually set these keys to the color 1, and therefore I can be sure that these keys are kind of grayed out and not meant to be played. So I do this by making a variable called keys, and I get the key properties. And for a little for loop for I0 up to 20, I'll set my keys number at this specific step to the color 1. So it goes through and colors these all with the color 1. I could use this also for setting different colors for different regions of the keyboard. If you have some special kind of key switches or special regions holding a certain type of samples and you want to divide this, you can color them pretty easily by this. After that, I created some variables that address some destinations in the script that I used more than once. At first, bus leads to this.parent getBus taped vibe fx. It holds the path from this.parent, which is the MIDI module itself, and it looks for the taped vibes fx bus, which holds all the effects. Then I also created variables for all used effects. One for the main layer, for the main sound layer, where all the reampings and all the layers are in. And then going further in the hierarchy, all the 3 different types of reampings, so the DI, the tape, and the preamp. So it's 3 different sound sources. And for the 3 different sound sources, I also created variables for the release layer of each individual sound source. I'm creating these first lines usually while I'm scripting. So whenever I go to a point that I have to address an effect more than once, I make a variable out of it to make my actual code simpler and more easy readable. And with the highlighting features in VS Code, I easily can select one variable on top of the script and can jump to the part where it's actually used. This furthermore helps and prevents me of writing typos. So for example, I go to tremolo and then I see in my overview, okay, here is some tremolo used, okay, here's the tremolo, and here's the tremolo variable used as well, twice. And this is actually pretty handy to dive through the script and go to the various parts where these variables are used. Let's continue with the first function. It is here and it's called onSampleSetChanged. Before defining the function, I made two variables, one preload level min and one max. With preload, I can specify which samples are ready to be streamed. By reducing the number, if, for example, the reampings are not used, I can save some memory. And taped wipes is not a big instrument, but having a large project with lots of instruments in, these numbers can sum up. So whenever I design an instrument, I try to save as much resources as I can. So this function call goes through an if clause, and it checks three different states. So when sound selection equals 1, the DI set parameter will get the value of preload level min. The other two reampings will be set to the max value. So min and the two max values. Else if sound selection equals 2, then the tape will be set to min and the other two to max. And if sound selection equals 3, the preamp will be set to min and the other two will be set to max. Now after the function you see a defined parameter named sound selection. And this parameter has three different strings and three different states named by these three different sound sources. And it also holds an onChanged, which calls this function onSampleSetChanged. This parameter is not automatable. So it's actually that easy. By calling sound selection on its string, it checks the state if 1, 2, or 3 is active, and accordingly it sets the preload level to min or max. So what happens in HALion? Let's quickly check this. On top level, so for the layer preset, the desired preload level has to be below the max setting that we are setting with the script. So in this case, it's 31. And as you can see, we have the desired preload level, and this is 31. So whenever a layer has preload level that is higher than 31, it will be not loaded into its program. So these sounds or these samples are not available for streaming. So let's have a quick look. So for the DI in this case, the preload level is set to 32. So no samples of the DI layer are currently loaded into the program, and there's also no processing happening in this and the layers beneath this. So tape is the preload level, as you can see, is jumped to 0. And for the preamp itself, it jumped to 32. So let's have a quick look at the macro page. As you can see, okay, the tape sound is loaded, so it's working correct. In other words, if I would just mute the DI and the preamp layer, all MIDI notes would be processed. All samples would be loaded into the RAM, etc. Because the mute can be undone anytime, and then you would expect the sound to come immediately back. So with the preload function, this can take a little time to activate this layer, but as this is a switch between three different sound sources in our case, the amount of samples isn't that big. So there is no real noticeable waiting time for the customer to switch between the different samples. And this kind of preload handling is also very useful if you have, for example, multiple microphone systems on, let's say, a larger scale library like a piano or a string library or so on and so forth. Going on with the script, the next part of the script covers the release functionality. This is somehow a little more complicated, and that's why I also wrote 2 lines of comments up there. So there's an amp-env parameter which saves the current value and restores it when switching between the release samples and the envelope release. So what does it mean in the end? The user can decide whether he uses the recorded release sounds or he wants the envelope to cover the release. So there you can increase and decrease the release length. It's like the behavior on a synthesizer. And as this release time in the background is adjusted to work as kind of perfect crossfade between the held note and the recorded release sounds, this time value has to be recovered when switched back to the release state that uses the real recorded samples. But when you want your envelope release again, your previous set percentage of this length should be restored. And that's why I created a kind of dummy parameter, the second quick control in here on this taped vibes layer, where the amp envelope will be set and restored when switching between these states. So the envelope release parameter triggers this function to check from which state you're currently coming. And with this if clause, it sets some parameters. So if the envelope release is true, it sets a parameter on the main layer, the quick control QC2, and it saves this emp envelope time. So this is basically the parameter that is connected to the macro page. And it sets this to the quick control. So my dummy parameter where it holds the correct value. And for the other three release layers, and these are holding the samples, it sets a parameter layer MIDI mute. So the set parameter layer MIDI mute is kind of interesting because with this parameter, you can exclude a layer to be MIDI processed. So this layer won't receive MIDI messages, but it is still kind of on hold to be processed, like an effect bypass. So you bypass the processing of the specific layer. So in our case, you bypass the processing of all release layers when the envelope release is happening, or vice versa. Here you activate these release layers again. You get the parameter of this quick control, and then after you have this, you'll set the quick control to be 50, because 50 is the dialed in center value. That is the ideal crossfade time between the sustain sound and the release. Next up in the script, there is our random function. So the hidden Easter egg that can be triggered on this center screw of the macro page. The whole function, so this on random that goes down till here, is set into one undo block to ensure that you can trigger the random multiple times and go back a few random states. So the amount of undos is set by your undo setting on the options page. You can dial this in HALion. So there's an undo limit. In my case, it's 20. When multiple things are getting randomized, it quite often happens that the sound is not convincing and you press random quite fast multiple times. And then at a specific point, you're saying, okay, the sound 2 randoms before was actually pretty good. And that's why I made all these changes into one undo block. So at first, you see a local variable called true and false, which has 2 states, true and false. This double dot refers to the script, and the character bypass or the mod bypass, they are script parameter, and you will see them later. So for these 4 bypass parameters, there will be set a random state so that they will become active or bypassed. So in this case, these 4 bypasses refer to 4 sections. So the character section, the mod section, the mod bypass, this is this switch, the delay bypass, and the reverb bypass. And with this little state, you're randomizing the modules to be active or not. After this first randomization, I created 4 if clauses that first check if the bypass is false, so if it's active or not. And if the bypass is false, so the effect is running, then the parameter of the effects will get a random value as well. Otherwise, these parameters won't be processed. So for most of the parameters, the random value will be between 0 and 100. But here, for example, for the modulation preset, random, it will give back a value between 0 and 8, as there are only 8 modulation presets available. And same for the delay presets and same for the reverb presets. After all these randomizations, the undo block will be ended and the random parameter will be set false again so that you are able to re-trigger. So one thing regarding the parameter definition of this random parameter, automatable equals false. So the random parameter cannot be automated, and it's also a not persistent. So you can't save it within the preset. It will always start in its false state if you load up any preset or if you load up your DAW with HALion Sonic or HALion hosting the taped vibes instrument. So this function is only available for user interaction on the macro page. But If you are happy with the values that came out of your random trigger, you can of course save this as a preset or save your DAW session, and then you can load up the same preset over and over again. The next script section shows all modulation presets. This is basically a big table holding parameters and values. I will show you later how you easily can save these values and so that you can design your presets and get this kind of table afterwards. But what's interesting is how you can make these presets accessible with the use of script. So there I created onLoad mod preset function. But first I call the assert function on chorus, flanger and phaser, as these three effects make up the modulation presets. If this assert function gets false, it would raise an error. And that's why I call it before we send some values to the parameters of the effect. Then we have 3 for loops that are setting values to the parameters that are listed in the table above. And the parameter for the user, where we can select the preset, is in another part of the script, but I copy it next to the function so that we can get fully through what's happening in the script. So here's the define parameter that is used for the modulation presets. When a user selects a modulation preset, so he is changing this parameter, this parameter holds a string list that is called mod preset names. So the string list will be firstly initialized and created, so it's an empty table. So, and there is a little for loop written that goes through the huge table with all the modulation presets. This table is called mod presets. And for every key I, it reads out the name mod preset name and creates a key value pair inside our new table called mod preset names. So when choosing a mod preset, the parameter has access to the preset names and gives back the number of the selected presets. It also calls the function onLoad mod preset, which first checks if chorus, flanger and phaser is available with the assert function and then sets all values to the dedicated parameter. So for a parameter and value in pairs of the mod presets table, so our big table, at the position modulation preset, so for example the 5th preset or the one that the user has chosen, and it checks the nested table chorus settings, do chorus, this is defined on top of our LUA script, set my value parameter to the parameter mentioned. So how does it look like? Let's say 1, 2, 3, 4, 5. Let's say out of tune, this preset has been chosen by the user. And then it goes through the chorus settings. So it's a nested table inside this big table. And then we have parameter value pairs. So the rate of the chorus setting for the out of tune preset equals this number here. The depth is 100, the phase, blah, 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 and so on and so forth. And when this preset is chosen, it goes through the chorus settings, through the flanger settings, and the phases settings as well. Let's quickly have a look at the HALion parameter list for the chorus, for example. So there you will find all the parameter names. This has to be the exact same name and typing as in the LUA script. So that by calling the set parameter in LUA, it will find the destination parameter in HALion and will be able to set the value to the right parameter. And then the same will be done with flanger and phaser as well. Let's go back to the script. And if we scroll down the script, you will see kind of the same for reverb presets that are defined here. And here you have the reverb loading mechanism. So also an onLoad reverb function, which asserts the reverb and then goes through the parameter value pair of this table. You have the reverb preset names as a table, and then the define parameter select reverb. So this define parameter select reverb, you can find this in our script. So you have the select reverb here, and this string list is created by going with this for loop through our reverb presets, so the huge table. And then this gives back a certain number. Let's say preset number 3 is selected by the user. And then this select reverb parameter, as this gets changed, it also calls the function on load reverb. And then it sets the right values to the parameters. And the same is done for the delay. You can scroll through this by yourself as well. The next little section covers some FX bypass functions. So when the mod bypass function gets called, chorus, flanger, and phaser will be either bypassed or not. And the same is done with the character FX, where I wanted the clipper, as you can see. So this is a distortion effect and the tremolo to be bypassed at the same time. Next here's the modulation presets line that I copied for readability. And the mod bypass and the character bypass parameters are defined in here. And they call the function on mod bypass or character bypass, which are defined up here in this section. Now, let's quickly check the last important script function, which handles the pedal noise trigger. I defined a slot local variable called noise IDs. What is slot local? In HALion Sonic or HALion, you can load the same program to several slots. So that the parameters aren't synced between the different slots, you can declare them as slot local. And now we have a slot local noise IDs empty table, and we define the last noise layer index to be 0 and the pad down state to be false. But let's have a look at the function itself. OnController is a callback function which receives all CC controller data coming from your MIDI keyboard or your DAW. But as we only take care of the sustain pedal, we need an if clause. So if the event controller is equal to 64, then we need the pedal noise to be triggered. We need a nested if function, so an if clause inside an if clause that checks whether the value of the CC controller data on channel 64 is greater or equal than 64, so half of the controller range. In the beginning, we declared pad down as Boolean state to be false. So there are only two states available. The pedal is pressed or not. So if the pad down is false, then we define a noise layer index to be 0. Why do we need another noise layer index? We have several round robins of the pedal noise, but no module defining which alternate should be triggered. So in this case, this is handled entirely by the script. So it repeats generating a random integer until it obtains a different one than the last noise layer index. So it's a kind of random exclusive behavior. Shown here in HALion, you have these 7 round robins and it alternates through. This then inserts with the LUA function table insert the noise ID and triggers a play note function. Play note is, depending on the instrument that you are creating, a very powerful function where you can generate note events out of the script. So check the reference for this function. It can be very helpful in a lot of scenarios. But in our case, it's simply sending the MIDI note number 0 with the velocity 127, and -1 in this case stands for the default duration, and it triggers the pedal noise. So this parent get layer, pedal noise, and inside this pedal noise layer, which is here, it gets the layer with the noise layer index, which comes out of this loop. So our last noise layer index will be set to the now triggered one, and then the pad down state will be set to true. So else if the number of noise IDs is greater than 0, so there is already a pedal noise sound triggered and an entry in the table of noise IDs available, then the release voice function will be triggered and this specific noise will be released again. This table noise IDs will be emptied afterwards and the pad down state will be set false again. Post event is a function to post the event, so the controller data that was coming in, to the engine again so that it will be further processed. This pedal noise trigger is definitely not beginner friendly, but take your time to read yourself through the code, and if needed, look up some of the functions on our developer GitHub page. There are also more examples that are worth exploring, especially for this played note function up here. One big advantage of handling this pedal noise trigger with this function is that you cover the two different pedal types. So there are some sustain pedals that only send an on-off state, so 0 or 127, and others are sending continuous values. But with our second if clause, so this one in here, where the event value has to be equal or greater than 64, you cover both kind of pedal scenarios in a pretty good way. The last part of my script are two helping functions for printing the parameters and values in a way that you can simply copy the script output text and paste it into your code to make the values available for the script. This contains only print functions and get parameter functions that first print out the name of the parameter, and in the value field of the get parameter you will get back the number that the parameter has in its current states while this gets printed out. Let's make a quick example and dial in a reverb preset. So we'll get to the reverb module and dial in some various settings. I don't know, I just changed a lot of parameters in here. It's all fine. Let's say this is sounding fantastic and I want this preset be available for the customer. So I can go back to my script and can simply activate this function print reverb setting once, and then I get a kind of formatted output in here, and it is super similar to my kind of format that I have in here for holding my reverb presets inside my reverb preset table. So I can simply, here's the copy code function, I get this copy to my clipboard and I can insert this into my table, and now I have this available for the customer as well. I called this give me a name please, so I can define the reverb name, fantastic reverb preset. And this will be available for the customer afterwards. So it's pretty easy. I did the same for the modulation settings as well. And if you print out the mod settings, you will get this kind of table formatted like this. So this is the end of the scripting episode. I hope you stayed with me up to this point. I know that these kind of topics can be very, very challenging. Even if written examples exist, I still wanted to create a YouTube video to show you the possibilities of the LUA scripting inside of HALion using a specific example, and the taped vibes instrument was kind of a good compromise between not too easy but not too complex at the same. The next episode will be all around the macro page creation process, so designing the user interface, connecting some knobs and customize them. And I will split this into two videos as well, like I did with the scripting. So I make a more general introduction into the macro page design, and then I will do one video going through the complete macro page process of the taped vibe instrument. So if you found this video helpful, subscribe to the channel and like this one, and see you in the next episode. Bye.